Alright, so in this video I will be going over a relatively basic calculation as a chemical process engineer. Now, at some point in your career, probably very early in your career, you'll be dealing with a pump and a piping system. It'll be delivering fluid from, you name it, pond to tank, tank to reactor, reactor to thickener, clarifier, settler, whatever. It could be a lot of different things, but essentially you're pumping fluid or delivering fluid from one place to another, and you're going to want to know how many pounds per day. If you're living on this side of the world, you're going to want to know how many pounds per day of some sort of substance that you got from point A to point B. In doing that, you're going to need two measurements, and only two measurements. You'll need a flow and you'll need a grade or concentration. Flow is almost always measured in gallons per minute on this side of the world. If it's in liters per minute, that's great. If you've watched any of my videos, you know I have a undying hatred would be too strong of a word, but I really don't like the English system. It just doesn't make a whole lot of sense. But nevertheless, I'm going to show you how to do probably the most complex version of this, and then we'll walk our way through it and do an easier version. Like I said before, these calculator videos are to give you guys access to really basic engineering calculations that you won't have to do yourself. You're more than welcome to just watch these videos and look at the formulas and go right ahead and structure this sheet just as I've structured it. If you'd rather not do that, you can always go to the Patreon link in the description of this video and just download them. This sheet does not take up a lot of space, so it would be something very easy to add to any of your daily Excel sheets or any of your tracking sheets that you need to collect this data from. Again, this channel is about education, not about money. I just want to give you guys access to these resources if you're in need of a quick fix that you don't want to necessarily go and make on your own. But nevertheless, what you're going to do here is you're going to go from gallons per minute to pounds per day using that grade or that concentration. So you'll do gallons per minute. The first thing I would do is go into liters per minute. So you'll do gallons to liters. 1 gallon is 3.78541 liters. So if we go back to this, you will essentially multiply this by your 3.78541. That's going to get you liters per minute. You will then multiply this by your grade, which is grams per liter. This will get you grams per minute. And then you now have like I say, grams per minute, and then you will go from grams to pounds. So for every 1 pound, you'll have 453.592 grams. So you will then divide this by 453. I think it was 592. Sure was. And then when you do calculations like this in Excel, I like to over parenthesize everything. That way, as you talk yourself through it, it makes the most sense. So you have this, you have that. So this whole thing will get you to pounds per minute. You will then multiply by 60 because you have 60 minutes in an hour, and then you will multiply by 24 because you have 24 hours in a day. So if you were flowing 456 gallons per minute of something that had a concentration of 0.97 grams per liter, you would have made approximately 5,315.53 pounds that day. As always, clean everything up so it looks the right way. Now, if you worked at a place that had something similar, but your flow was in liters per minute, you would take out the conversion of gallons to liters. You would just have this. So, like I say, you'll notice that it's essentially just 3 times less, or more like 3.78541 times less than this. And now we can play a little bit more with this. If your flow was in liters per minute, but your excuse me, your concentration was in pounds per gallon, you would do liters per minute, and we can walk through this half of the formula one more time, just as an exercise to go through it. If you're in liters per minute, that's awesome. I would do, because your units are in gallons, I would get you to gallons immediately. So I would divide by that, I believe it was 3.5, yeah, 3.78541. 3.78541, and then I would slap a parentheses on it. So now you are in gallons per minute rather than liters per minute, and then I would multiply by your concentration of pounds per gallon. That's going to give you pounds per minute. And then multiply by the 60 for 60 minutes an hour, and then 24 for 24 hours in a day. So what's changing here and why this number is so large is your concentration in pounds per gallon. If you had 0.97 pounds in 1 gallon, that's pretty heavy density. It's a lot more than 0.97 grams per liter, but nevertheless, there's only one more iteration of this, and I'm sure you can see where I'm going with it. If you had gallons per minute and pounds per gallon, you would start yourself off with this. So you have gallons per minute. There's no need to convert to liters at all. You would just straight up multiply by gallons per minute times pounds per gallon. That's going to get you pounds per minute, and then just slap a parenthesis on it, and there you go. This is even larger because gallons are more than liters and pounds are more than grams. So just very quick calculation right here. Again, if you wanted to change pounds per day into kilograms per day or something like that, you could very easily just swap over here, right? Make these the same size. You would just go from pounds to kilograms, then you would do this conversion. So for every 1 pound, you have 0.453592 kilograms. So this would equal this number multiplied by that number. And this would be kilograms per day. And it truly is as simple as that. And you'll notice it just keeps referencing itself. And I am not really going to go into the rest of the calculations we could do here. So like obviously you could do pounds and kilograms per month, pounds and kilograms per year, pounds and kilograms per whatever. But at the end of the day, make sure that this flow represents the denominator of this unit. So like this should be the average flow for the day, the average liters per minute for the day, liters per minute, gallons per minute, gallons per minute. And then these concentrations should be sampled on the day that you're looking at that flow. I should make that very clear. Again, like I said, you guys could probably just make this sheet on your own. That's awesome. Go right ahead. Feel free to have the exercise. But if not, this is an available sheet in the Patreon link in the description of the video. So thanks again, and hope this video helps.